What is up, my beautiful YouTube people, and welcome back to episode 20 of the Chaos Daily. We're up to 20 already. Time flies. So let's get straight into this. There's a lot to go over. First off, I've had a number of really helpful and useful and awesome and amazing comments from both a YouTube viewer and a forum member, as well as one of my Patreon members, Simon. Yes, Simon makes a return to the daily, a feature of the daily episode. So let's see what Simon had to say first, because it was the first thing I saw when I woke up this morning. I saw Simon's comment in my Discord channel, and yeah, let's have a look at it. So Simon says, he's just watching my video. Question, why do I want to use the rudders? It's making them more harder to build, blah, blah, blah. To be honest, even the front canards don't really need to move. The ailerons can just do it all. Yep, so they're called elevons. You just have moving surfaces on the back of the aircraft, like on a delta or a flying wing. They're called elevons because it's a cross between aileron and elevator. Don't ask me, I didn't make up the rules. Anyways, they're called elevons. And quick and easy. I think the design is simple and probably make an option of adding the canards if you want them later on. And I think this is fantastic. Just screw all the complexity, just simplify the hell out of the design. Let's go straight to absolute basics. We're going to just stick a set of elevons on the back. I'll increase the size of the elevons, or the ailerons. They're now elevons, so I'll increase their surface area so we get more play out of them, so we can both use them for elevation and aileron control at the same time. So that's real simple. That brings us down to just need to deal with two servos, and it doesn't change the shape or design of the aircraft. I can still make the front canards elevators. They can still work that way, and honestly, I'm very tempted to just not deal with the rudder, but someone wants the rudder. Now this is a new face to the scene. I don't know how to pronounce his name correctly. I think it's Lasse, L-A-S-S-E, Lasse. Anyways, Lasse writes a lot. He had a lot to say. So, and it's not just here. He also made this post on RC forums in the Draco build. I haven't put a long easy thread in RC groups yet. So he wrote, he likes the project, looks really cool. Again, missed the information somehow. This is just referring to stuff to do with the Draco. We'll go over that tomorrow's Draco episode. He's just worried about the high wing taper, the shape of the wings and all that, asking about if I've done any fluid sims and anything like that. Yes, I fluid sim pretty much everything I design to varying degrees. I'm still learning how to use Autodesk CFD. It's a lot more comprehensive, there's a lot to it, and the tutorials and information about how to use it are very long-winded or sparse, or just a really nice Indian fella trying his very best to educate us English-speaking people about how to use something that he's probably excellent at, but unfortunately it's not the best when it comes to trying to understand his accent and listen carefully to what he's saying. So that's not his fault, that's just the world we live in. Anyways, let's keep on track. Lots to go over. And then he also left a comment on YouTube on episode 19 of the daily. Hey there, really good approach. Just a couple of questions. If you push the battery a little bit further, blah, blah. So yeah, with the battery, I did originally have the servo in front of the battery, but then I figured it wouldn't make that much difference to chuck it in the back, move some of the weight back just in case, because I'm worried my CG is going to be a little too forward for the center of lift. So I'm a little bit worried about that. That's why I've asked you on RC forums if I can get some more information about those things you mentioned in RC groups about the FXLR and FLZ Vortex. I would like to know more about those. I haven't had a chance to go and look that stuff up yet, so maybe consider becoming a patron. Join us in the Discord channel, and you can tell me all about it in real time. That would be very helpful. So yeah, moving the servo, make it easier rather than routing the linkage. Routing the linkage is not a big issue, but yeah, I can put the servo at the front. It doesn't really make much difference. But since we're going with elevons, the servo in the front for the canards is now going to be a optional extra upgrade package to it, so it'll be a different setup that I do once we get this working. We'll just focus on getting this flying and working, and I will make the adjustments as we go. And I've just put a buttload of work into the Long Easy today to get it back up to where it was, but I've gone a completely different route with all the file structure and the order operations and everything. It's madness, it's crazy. I don't ever normally do stuff like this. I've essentially done everything all at once as their own separate thing. So I have complete control over every aspect of all the different parts and their different elements and everything. And in the most convoluted way, the operations list is a mile long. I hate mile-long operations lists. I always try and keep things done in the shortest number of operations possible. But doing it this way means that if I want to change something on any one particular thing, I can go back in the order of operations list and change that thing there. And it doesn't have to necessarily update everything else in the list because they're all discrete, different operations towards different parts and stuff. So I don't have a cascade failure of operations if I tweak something further back. And I've tested this, I've made a number of tweaks already and it works really well. So I can make changes to the plane now without too much trouble and it all falling apart and me feeling like I've just made a tangled mess. Anyways, let's carry on. So he also mentions the aileron linkage, the 5mm carbon fiber tubes acting as torsional springs. No. Not over the distance what we're talking about for a 5mm carbon fiber tube. We're not talking about enough forces, torsional forces, from the airflow over the wing surface or from the servo being able to... If there is enough torsional force on the airflow of the wing surface to create a torsional spring effect with a 5mm carbon fiber tube, it's going to be busting the cheap servos that you're putting in this thing. Even my Metal Gear servos, these Metal Gear servos that I'll be using, they'll start to fail before that carbon fiber tube starts acting like a spring. So yeah, over longer distances, yes, and if your carbon fiber tubes are acting like torsional springs, I highly recommend finding another supplier because that's bad. That's the whole point of a tube, is that it's very good at transferring torsional loads. That's kind of why we use tubes and cylinders for, drive shafts and stuff like that. That's what the structural forces that play through the surface of the skin of the tube, that's how that works. So anyways, yeah, I'm not too worried about that. It's a minor issue. I am more worried about binding, and I mean like physical binding, not like binding your transmitter to your receiver. No, so when the wings flex under G loads or negative loads, when they start to flex, I am worried about that carbon fiber tube that is acting as the torsional transfer for the elevon. When the wing bends, it might cause it to pinch around the tube at certain points along the way between the elevon and the servo, which means when that starts to bend and it binds, then you're going to lose control until it rectifies and steadies out. So I'm more worried about that than I am about torsional loads on the carbon fiber tube. However, that's easy to mitigate because I just cut an elongated slot along the route between the elevon and the fuselage, and then I only have one point which is at the wing where the wing meets the elevon, and one point on the inside of the fuselage where it is a perfect circle with still enough tolerance for it to freely rotate. So that'll avoid any binding issues, I hope. We'll have to test it. I will actually, when I print this out, and it will depend between resin printing and plastic printing, because with resin you're going to have a lot less flex in the surface material than what you do with plastic. So designing this to work for both resin and plastic printing is going to be very interesting because, well, they have completely different material properties and behave completely different under different loads and situations. So anyways, moving on. Right, so torsional strengths, prone to flutter, direct linkage last, central rudder. Right, so if we do need a rudder on this plane, you've suggested doing what I said in the previous episode, where I'm just going to cut that little bit of the back of the pylon where the motor wires come through. I can use that last, say, like half an inch, 3/4 of an inch, and actually make that a little rudder that sits in the airstream of the high velocity airstream of the EDF. So you don't need a very large surface area for that. This plane is super tiny, it's super light, and if that's in the jet stream of the EDF, you only need a small rudder. You're going to get plenty of play off of that from what you need. So yeah, if we do need rudder, then yes, we will go with a centralized one. But for now, we're going to just go super simple. 2 servos, 2 elevons, fly, hopefully. Anyways, and further down the line, I will put the canards in and I'll put the rudder in if we need it. No more tips. It's just going to be dead tips. And your other really, this is the best part of your comment, is about the tips, the wing tips. You're worried about them being damaged, either with rough landings or during transport. So what I am doing is I'm designing the tips to be inserted and attached to the rest of the wing in a certain way so that if they are damaged for whatever reason, they can be easily replaced without damaging the rest of the wing. So I am working on that particular part of your comment because that was a really good point. I had thought of something along those lines beforehand, but I was more focused on other parts of the design. Now that I've gone through and actually done the full component layout and thought about basically everything all at once, all in one go, my head hurts. It's been a long day. I'm recording this episode quite late at night. This is going to be close. So that's happening. So thank you, Lace. I'm sorry. Tell me in the next comment how you pronounce your name, please. Lasse. Yeah, I'm just going to go with L. Mr. L. Thank you, Mr. L, for all of your help. Yeah, there's some genuinely good comments there, so thank you very much for that. But we're going to jump straight into a time-lapse because I've got one epic time-lapse for you guys to watch. Please do watch all of it, enjoy it, and at the end of it, we're going to go over what I've done, why I've done it, and why I am a frazzled mess and the beard is wild and loose right now. So, straight into time-lapse. Well, hello there. I jumped into the middle of the time lapse to give you some incredible news. What I really am doing is I finished recording the rest of this episode and then I just remembered, oh, I have exciting news to tell you. Yeah. My printer is on its way. I have a shipping date, 5th of February. Okay, back to the time lapse. Bye. what did I tell you? Was that a time lapse and a half, or was that a time lapse and a half? There is so much footage there. There's over 3 hours that I've had to condense for you guys. All right, but we're still not done. This is going to be the longest daily so far. Episode 20. Hey, why not? Let's make a big one out of it. Let's jump into inventory. So this is what the substructure looks like. I know, right? Is that wicked or what? So, if you guys really want to know how I do this fuselage structure, if you didn't catch how I do it in the time lapse, please let me know in a comment. I might do a tutorial on how to make this wicked crazy shape. It's when you find out how simple it is, you're gonna slap yourself. I'm gonna hear slaps all the way here in Australia from you guys slapping yourselves wherever you are. Anyways, so let us scroll up. Let's start by just look over there at this operations list. You see all the separate operations that I had to do to get this to where it is so far. And I'm not even done yet. This is only one half. I've got to do the other half now, which is just a bunch of mirroring operations, but it has to be done special because when I get to this top section, these are all individual parts, right? Or solids, because this is a single part file, but these are all individual solids, which means if I want to come in and make holes in all of these straight lines, well, there they are. So I can isolate just this one thing. I can go, right, all of this other stuff, disappear please. I need to work on that one thing. We need to have a chat, right? So there. So then I can come in and I can work on this to my heart's content, make changes, and it doesn't affect anything else. Same with everything else. It's all there. All the skin surfaces, all the shells, all the skin surfaces, they're all done. All the internal structures are done. The only things that aren't done are things like the wingtips and the canard tips. The plan with those is you just print them at whatever infill level you want. I'll make cutouts in them for the spars, to attach the spars, to assemble everything. But for the most part, I don't need to do anything with them. You print them on your printer at the infill with whatever infill pattern or design you want to print, and that's super simple. So that's less work for me to do. I don't need to deal with it. So let's go through these parts. Let's start with the EDF. So the EDF is broken up into two parts. We have the front inlet piece. This gets printed flat on this back ring. Same with the EDF on the back. That gets printed from that ring, from that face. And if you look, this line here is cut level with that inside line. So it'll print that whole thing face down, print it up, done. No overhangs. Maybe this will a bit of support material for here, not a problem. So I'm thinking about how these things print and what support materials you will need, if any. So everything in this is designed specifically for FDM printing. When I go to resin print mine, I will make a copy of the file and just Swiss cheese the whole thing because I don't need any of this internal structure that's in this thing. Barely any of it. Moving on, you will need support structures when you print the wing root and the wing end. They get printed on this surface and this surface respectively. You'd think you want to print the wing root from the root here on this surface, but then you get an overhang for this cutout on the inside here. And because it's only 0.5 millimeter thickness walls, that's not allowed. So yes, the overhang for this wall that's on this side, which will be at the top where the printer is, that'll droop when that prints that. So I'm going to have to work out ways to make that better. I'm probably going to put in some internal structure moving vertically along this like this, so that when it gets up to that point, it creates a bridge structure underneath it first before it prints that last flat layer. And then this one, yeah, you just print it same, and I'll put a bridging layer there. Those bridging layers would also help with securing any spars or rods or anything that go through and creating a beefier section of material for the whole of the rod. So what else? Okay, so I've shown you that everything is all in lots of separate solids and parts that I can still edit and change. These sketches that are still visible, these are here for cutting out all the holes for all the carbon fiber rods, tubes, spars, you name it. They're all part of that, and they can still be used to affect anything else in the scene. If we jump into the assembly file, where I have the EDF and everything and the servos, I just right click on this and go transparent. You can see in here, I've also made a much better battery cage, and I've worked out that we're not going to have any access hatches per se. So in order to access the battery and your transmitters and everything, the front end of the plane and the back end of the plane bisect. So they will split down the middle here where the mouse is. There's a split seam between the solids for this part of the aircraft and the solids for that part of the aircraft. So that'll come apart. You can pop your battery in the one end and wire it up, and then you got space for your transmitters and everything, and that all works nicely. And when we get round to doing the installation for these servos, I'm going to have an access hatch in the back here, but this access hatch does double duty. It's an access for you to get to the servos, but that access hatch I'm going to design with airflow holes, because this is where your ESC is going to sit in here. So I want airflow over that, and that airflow is going to is going to be drawn to the back and back out the top of the motor here, where there's this big vent hole for the heat from the motor. So all that air will also be brought along where the wires are traveling up to here and sucked out the back of the aircraft. So there's cooling for your ESCs and your batteries and everything. I'll probably put some NACA scoops somewhere to flow past the batteries to keep your batteries cool. Maybe, we'll see. It's no point making this overly complicated. But yeah, so that's pretty much it. Like, tell me what you guys think. That's another day's work. So in a day, each time that I've redone this and I've learned something new. So the first time I did it, it took me a day to get the design done. And then when I did the internal structures, it took me a day just to do the wing. And then when I did the fuselage structure, that took me a whole day. But then I redid it, and then it took me a day to do the fuselage and the wing and the design all in a day. And now it's taken me a day to do all of that plus more. So I've done pretty much 3 times the amount of work in a single day, just from learning this process of working on this and learning how this is the best practice to do this. I'm getting better at it. And this is the thing I love about doing CAD and design and engineering, is especially when you have to do things over again and repeat yourself, is because you learn how to get better at something. So yeah, so you learn how to get better at something, and I absolutely love that about this kind of work. And that's what I really want to try and share with you guys. It's a bit difficult because I'm not the best at teaching or doing tutorials. I haven't worked out how to do that kind of video format yet. So hopefully just by watching the time lapses, you might catch a glimpse of something, or you over time you might get the hang of what it is that I'm doing and what tools that I'm using to create certain shapes and the methodology that I use, basically. At some point in the future, I'll probably take some time to work out how to do a video tutorial format. The problem is it's very difficult to get that kind of just stagnant, boring information across in a way that is interesting to people. And then also, quite often, when people are searching for YouTube tutorials, they're searching for a way to do a specific thing. And they don't want to be sitting there watching a guy going, "Hi, I'm such and such, and welcome to my channel. You should check out my other videos," and blah, blah, blah. And then like 3 minutes later, he gets to start working on the tutorial. And then he's like, "This is how you make a cube. This is how you draw," and you want that thing that's like 7 minutes into the video. And yeah, for the most part, that's the sort of thing people are doing when they're looking up information on tutorials for CAD software. They want to get straight to the one thing that they don't know how to do. And people that don't know anything about CAD, I'm so sorry. There's just no entertaining way to teach people CAD. Well, sort of. TFI CAD Tips. He has the best tutorial set, so that's why I don't really do it myself, because it's kind of been done. And if you really want to know how to do CAD, or especially for Inventor, go check his videos out. The guy is just, thank you, Neil. Thank you so much. Anyways, let's end this here because, oh boy, this is going to be a long episode. We're up onto like, what, half an hour now, I think? I don't know. I haven't even started editing yet. I am just going at 1,000,000 miles an hour today. So, yeah, I've been Chaos, and as always, expect the unexpected. And until next time, I will see you guys later. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.